Good afternoon, class. This is College Algebra at College of the Sequoias, Math 35. And today we're going to be covering a couple sections. The first section is going to be 4.5, and that is on solving equations with logarithms and exponentials. Okay. So a couple things we're going to use in both of these. We usually have x is greater than 0, y is greater than 0, and a is greater than 0, but a does not equal 1. That's boring. And recall that we had if x equals y, then log base b of x equals log base b of y. This is almost like saying treat taking the logarithms of both sides as an operation. The only requirement is you must use the same base on each side. Okay, so let's take a look at some examples. Our first example is going to be solve 8 to the x equals 21. Now, we could try to guess and check this. I mean, what do I got to do to get this? 8 squared is 64. That's too high. 8 to the 1.5. Well, that's 22. I'm getting close. 8 to the 1.4. Too low. So somewhere between 1.4 and 1.5. I'm sure it's going to have a lot of decimal places. It's easier to take the log of both sides. Take the log of both sides. Choose your base. Now, sometimes the problem guides the base. If they're both powers or multiples of 3 or 2 or something like that, we might choose base 2 or 3. But when they don't have anything in common, like 8 and 21, we want to choose the base such that we can use a calculator. So good choices are b equals 10 or e. If I take the log base, let's say 10. If I say I've got 8 to the x equals 21, I'm meant to give myself a little bit more room, 21. And I say log base 10 of that and log base 10 of that. I'm going to pause because I'm about ready to go to another page. So pause your screen and take some notes. What can I do with that? Well, I could make that look like a better 8 first off. There we go. Well, this x here is an exponent, and now it's inside the logarithm. I can pull the x out. Pull the x out using logarithm rules or properties of logs. Remember, the exponents can go out front. I have x times log base 10 of e equals log base 10 of 21. These are just numbers. Log base 10 of 8 on both sides. And I get x equals log base 10 of 21 over log base 10 of 8, which is exact. Or we can get an approximation using a calculator. Log of 21 divided by log of 8. Remember the log when no base assigned is 10. And I get 1.464. And that's approximate. There's a little bit more. It's an approximation. If you wanted to be real clever, this is exact. If you want to be real clever, remember we could use the change of base and actually make this work backwards. Say this is log base 8 of 21. Those are the same thing, but this isn't calculatable easily unless you have a table, and we're better off using a calculator. So that's the idea of things we're going to do. You guys ready for more? All right, let's take a look at another problem. I'm going to have 5 to the 2x minus 3 equals 8 to the x plus 1. Again, I have 5 and 8. They are different numbers with nothing in common. I'm going to take a log using a base that I have in the calculator. This time, let's go with base e. Remember, log base e on the calculator is ln. So I'm going to take the natural log of both sides. Try pausing it and working it out how I did last time. See what you come up with. All right, I'll assume you paused. In both circumstances, we can pull the exponents out front. 5 equals x plus 1 times ln of 8. We're going to distribute. I'm going to say 2 ln of 5. That's my coefficient times x minus 3 ln of 5. And we'll distribute here. X times ln of 8. That's a coefficient. It's just a value plus ln of 8. I'm going to gather all my x's on one side. So I'll subtract natural log of 8 from both sides, or natural log of 8x. And I'll add 3 natural log of 5 to both sides, because we're going to gather all our constants on the right. Now I've got 2 natural log of 5x minus natural log of 8x equals natural log of 8 plus 3 times the natural log of 5. This is like one of the tricky problems we did when we were working with finding the inverse. Remember, these both have x's in them, and we can factor that out. This becomes 2 natural log of 5 minus natural log of 8 times x equals natural log of 8 plus 3 natural log of 5. Now, this is just a coefficient. We divide both sides by it. And that's the exact answer. Natural log of 8 plus 3 natural log of 5 over 2 natural log of 5 minus natural log of 8. That's exact. If we throw it into a calculator, we get an approximation. Let's see, what's the top? I've got natural log of 8 plus 3 times the natural log of 5. I'm going to do this in a couple steps. And you shouldn't stop on the calculator, but you can. You kind of want to do this all as one operation. Let's see what the bottom is. 2 natural log, delete, times natural log of 5. Did it again. Minus natural log of 8. Three, 9, 4, 3, 4, 2, 8, 3. That's the bottom and top separately. I'm going to leave that in the answer. I'm going to redo what I had and do it all as one operation. Natural log of 8 plus, parentheses, natural log of 8 plus 3 times natural log of 5, then parentheses, and I'm going to divide it by my answer that I have stored. That does it all at once. And we get that value right there. This is approximately 6.062 to 3 decimal places. All right. Okay, ready for another? I want you guys to pause this one and try this on your own. We're going to do e to the absolute value of x equals 50. Okay, I'll assume you did it. I can choose the e and 50 don't have anything in common. So I can choose base 10 or base e. If I choose base e, I can use something nice. So we're going to use base e, which gives us the natural log. My absolute value of x comes down, and I have ln of e equals ln of 50. But ln of e is log base e of e. And do you guys remember what that equals? Log base b of b always equals 1. So this is just 1. And I have the absolute value of x equals the natural log of 50, which means x equals plus or minus the natural log of 50. Those are exact answers. If we want an approximation, we can use a calculator. X is approximately plus or minus 3.912. And here, x can be negative because we're taking the absolute value of it when we're done. Let me do that again. Let's say negative natural log of 50. And I take the absolute value sign of it, so I make it positive. And I'm going to raise that as an exponent to e. Where is that on my calculator? Shift e. So it did it. All right. Ooh, this one's fun. This one's fun. Let's do this one. E to the 4x times e to the x minus 1 equals 5e. What can I do here? Well, first off, I want to address this multiplication. What happens if I have Let's see if you guys remember the rules. X to the m power times x to the n power equals what? X to the m plus n. Also, x to the m divided by x to the n is x to the m minus n. So we're going to use those rules right now. The first thing we're going to do, we'll use the multiplication one to add these exponents. This turns into e to the 4x plus x minus 1 equals 5e, which is e to the 5x minus 1. And if I don't have this 5 here, I could have e's on both sides. It'd be easy to take the natural log. Maybe we should get all the e's on the same side. This is really like e to the first. So let's divide both sides by e to the first. They cancel out over here, leaving behind ones. This turns into e to the 5x minus 1 minus another one from down here by that property, which is e to the 5x minus 2 equals 5. Now, take the natural log of both sides. I'm going to say natural log of this side and natural log of that side. I can pull the 5x minus 2 down now. Equals natural log of 5. Natural log of e, though, is 1. We just got done showing that. So I have 5x minus 2 equals natural log of 5. When you solve for x, it's 2 plus the natural log of 5 divided by 5. And this is, of course, this is the exact one. It's always good to show the exact one, especially on a test or when you're doing work, because then someone can always verify that the next step is a very common way to make mistakes, calculator errors. So what happens when I throw this in a calculator? I'll say 2 parentheses, 2 plus natural log of 5 end parentheses, and then I'm going to divide by 5. And it looks like to 3 decimal places. What do we have? X is approximately 0.722. Okay. Let me give you guys one to try. Now that we've illustrated how to do something like this, why don't you try? We're going to do e to the 3x times e to the x plus 4 equals 7e squared. Pause the video for a moment, take a jab at it. Okay, I'm going to assume you did. First thing we do is we add these exponents. 3x plus x plus 4 equals e to the 4x plus 4. And the right side is still 7e squared. Now we'll divide both sides by the e squared to get all the e's together, which turns that into subtraction. We'll subtract that exponent, and we get e to the 4x plus 2 equals 7. And now we can take the natural log of both sides. I'll bring the 4x plus 2 down. Again, this equals 1. So we've got 4x plus 2 equals natural log of 7. Subtract 2 from both sides. Divide by 4. Which is the exact answer, what you want to have. But if we approximate it, it's approximately negative 0.01. Let's show 3 significant digits, 135. All right. So that's how to solve some of those problems. Those are exponential problems. There's another form of the exponential problem. Let's take a gander at it. So here we're going to do something like this. We're going to have e to the 2x minus 6e to the x plus 5 equals 0. What does this look like to you guys? Maybe it'll be clearer if I show it like this. That is e to the x squared minus 6e to the x plus 5 equals 0. This is in quadratic form. Ax squared plus bx plus c equals 0, quadratic form. So let's do a U-substitution. Substitution. Let's say u equals e to the x. If we do this, though, when we finish, replace u with e to the x. So I've got u squared minus 6u plus 5 equals 0. I'm just making the e to the x turn into a u. Is this factorable, or use the quadratic formula? For me, it factors. I can recognize it. We need things that multiply to positive 5 but add to negative 6. When they're one apart like that, they tend to be this number and 1. And it needs to be negative so that we end up with negative 6. So I get u minus 1 equals 0, or u minus 5 equals 0. U equals 1, or u equals 5. And now we replace. We have e to the x equals 1, or e to the x equals 5. Now, how do we deal with this? Well, we take the natural log of both sides. Here I have ln of e to the x equals ln of 1, or ln of e to the x equals ln of 5. The x comes out. And recall, the natural log of e is 1. So I get x equals natural log of 1 or natural log of 5. Log of anything that have 1 is always 0. So x equals 0 or natural log of 5. X is equals 0 or approximately 1.609. Do they both work? Let's check. So check x equals 0. I have e to the 2 times 0 minus 6, e to the 0 plus 5. Does that equal 0? These both end up being e to the 0, and anything to the 0 power is 1. So 1 minus 6 times 1 plus 5. Does that equal 0? 1 minus 6 is negative 5. And that does equal 0. So x equals 0 works. We'll try the other one. E, the 2 times natural log of 5 minus 6e to the natural log of 5 plus 5. Does that equal 0? Now, it's important that you recognize that ln is really saying e log base e. And no matter what that is, the e and the log e, we had that. An exponent raised to the log with the same base is just the value. So e to the natural log of 5, this just is 5. I can't do that here yet because I have the 2 out front. But recall, I can move the 2 up as an exponent. I have e to the natural log of 5 squared minus 6 times 5 plus 5. Does that equal 0? And now we can do that property. Six times 5 is 30. Does that equal 0? And we follow it through. 5 squared is 25. 25 minus 30 is negative 5. And that one works also. So x equals 0 or natural log of 5. Let me give you guys one to try. Let's see what I want to pick. Let's try e to the 2x minus e to the x plus 6 equals 0. Pause it and try to give that a try. Okay. We're going to make the substitution u equals e to the x. Recall, this is e to the x squared, like that. This becomes u squared minus u plus 6 equals 0. I need to make it minus 6. All right, pause it, try that. I think I gave you a problem that's not really all that solvable easily. It's going to give you ugly numbers. My bad. This one does factor. It's u minus 3 times u plus 2. That's what I meant to do. And we saw we get u equals 3 or u equals -2. And we replace u with e to the x. So this is where we take the natural log of both sides. I want you to recall, though, what the graph of the exponential looks like. This will save you some steps. Recall, if this is our Cartesian system, x, y, and this is 1, e to the x goes like this. Y equals e to the x is always greater than 0, which means e to the x cannot equal -2. That solution is out. Just this one. We'll take the natural log of both sides. Bring the exponent down. Natural log of e is 1. So x equals natural log of 3. Which is approximately 1.099. You're better off having both answers. Natural log of 3 is exact. And we can check it, we can put it in. E to the 2 times natural log of 3 minus e to the natural log of 3 minus 6, does that equal 0? Remember, I got to move this 2 up as an exponent. E to the natural log of 3 squared minus e to the natural log of 3 minus 6, does that equal 0? E and the natural log cancel out. We get 3 squared minus 3 minus 6, does that equal 0? 9 minus 3 minus 6 does equal 0. So x equals the natural log of 3. I wish I hadn't put the wrong problem down first. I kind of made it up on the spot. That was on how to solve exponential problems. And what we did is we used the logs. We used their inverses. Let's take a look at solving logarithmic logarithm problems. So let's say we've got 4 times the natural log of x equals 36. We used logs to get rid of exponents. Exponentials turns it into a regular equation. Let's use exponentials to get rid of logs. And what we're going to do is we're going to isolate the log and then raise or treat each side as an exponent for the same base. And the problem guides the base. You want to do it such that it clears out what you have there. So right now, we've got 4 times the natural log of x equals 36. The natural log of x isn't by itself. I can either move it up as an exponent, or I can just divide by 4. That seems like an easier thing to do. And now, what I mean by treat each side as an exponent, natural log of x is log base e of x. I want to use the base so that the log clears. Which means we need the same base. Natural log has a base of e, so I need to treat each of these as exponents on natural log, or e. This is e log e of x. And we said the e log e cancels out. We get x equals, oops, that's a 9. X equals e to the 9th, which is very much an exact answer. If you really want to know how big it is, oops, 8,103. Doesn't sound that big, does it? I'd just leave it at e to the 9th. All right, let's explore more. Does this work though? Actually, let's check it. We should check it. Let's check it. I've got 4 natural log of e to the 9th equals 9. I can bring the 9 out front. Not 9, 36. That was the first problem. First problem was 36. Natural log of e is 1. 4 times 9 does equal 36. And the reason why we check it, we need to check it, check our solutions, because we cannot have negative values inside logarithms. If we have log of x, x has to be greater than 0. We don't even want a 0 in there. Can't have negatives or 0. Okay, let's take a look at another example. Let's start off, we're going to have x cubed minus 5 equals 1. Sorry, log base 3 of x cubed 3. Let's try this over. Log base 3, did it again. Log base 3 of x cubed minus 5 equals 1. Use the current base. I'm going to treat these as both as exponents on base 3. Because that's the base of my log. Oop. Just 3 to the first. The left side, the 3 log 3 goes away, and we just have x cubed minus 5 equals 3 to the first power is just 3. Now we solve. We take the cube root of both sides, and we get x equals 2. Check it. Log base 3 of 2 cubed minus 5, does that equal 1? If log base 3 of 8 minus 5, does that equal 1? Log base 3 of 3, yes, that's the property where the base matches the argument. We have it works. So x equals 2 is a valid solution. Don't just look at this and say it's greater than 0. The argument had to be greater than 0. X cubed minus 5 had to be greater than 0. Okay? All right, let's take a look at another one. This is adds more to it. We're going to do log of 2x plus 1 plus log of x equals log of x plus 8. We only want a single log on each side. How can I combine these? How do I combine? Hopefully you did the homework using on the section with logarithms first. Recall, addition on the outside turns into multiplication on the inside. So I have log of 2x squared plus x equals log of x plus 8. What base? When it doesn't show it, b equals 10 if it isn't shown. I can put a 10 in. So this is 10 to the log 10 of 2x squared plus x equals 10 to the log 10 of x plus 8. 2x squared plus x equals x plus 8. The 10 log 10 cancel. This looks like it's going to be quadratic, so let's move everything to one side. having that x go away, this actually gets a little bit easier. Let's put that 8 back over on the other side. Because I don't need to factor here, I can divide by 2. When I just have a square and no x, it's easier just to take the square root. Take the square root, and we get x equals plus or minus 2. Now we have to check both in the original equation. When you do this, as soon as you see negative argument, you can stop. That solution doesn't work. All right, pause it. Let's check them. I need some more room. I'm going to rewrite down my equation. The very initial one was log of 2x plus 1 plus log of x equals log of x plus 8. And now we had x equals plus or minus 2. Let's check the positive one. Log of 2 times 2 plus 1 plus log of 2, does that equal log of 2 plus 8? 2 times 2 is 4 plus 1 is 5. And 2 plus 8 is 10. I don't have any negative arguments. This should pan out. We can put this together as 5 times 2 using the properties. And we see that one does work. 5 times 2 is 10, and we get log base 10 on both sides. X equals 2 is a valid solution. Now we'll check x equals negative 2. Log of 2 times negative 2 plus 1 plus log of negative 2, stop. That's negative. I see it's negative already. I could see this one's negative if I worked it out in my head real quick, but I already see this one's negative. If you don't do that multiplication in your head, you may not notice it right away. This one I notice right away is negative. X equals negative 2 is not a solution. Only x equals 2 solves the equation. Okay. Let's kick it up a notch. Give you a fun one to try because we're having fun, aren't we? Woo woo! Log base 3. We're going to have 4x plus 1 times x plus 1 equals 3. Try to solve this. Okay. We're going to use the base here as to guide us for choosing a base for the exponent. I'm going to treat this side as an exponent for base 3, and I'm going to choose that as an exponent for base 3. That's my lazy way of doing it without having to rewrite the line. The 3 log 3 cancels. And I get 4x plus 1 times x plus 1 equals 3 cubed, which is 27. So let's distribute. I get 4x squared plus 4x plus x plus 1 equals 27. I'll subtract 27 over and combine like terms. 5x minus 26 equals 0. A times c is 4 times negative 26 is negative 104. B equals 5. Does this factor 13 times negative 8 gives us negative 104, and 13 plus negative 8 gives us 5. So you can factor this, or you could have used the quadratic formula. If you use the quadratic formula, you're going to have a different approach. This tells me I have 13 and negative 8 as my how I split it up. So I got 4x squared plus 13x minus 8x minus 26, 0. Pull out an x here, and I get 4x plus 13. I should end up with 4x plus 13 again, which means I have to pull out a negative 2. And we set each of these to 0. X equals 2 or negative 13 over 4. Don't assume that since it's negative, it doesn't work. Check them. Don't assume negative 13 over 4 won't work. I said the argument can't be negative. Let's just check the argument for now. Let's see if it's positive. Is that greater than 0? If we try x equals 2, I get 4 times 2 plus 1, and 2 plus 1, is that greater than 0? 4 times 2 is 8, plus 1 is 9. 9 times 3 is 27, that's greater than 0. We have log base 3 of 27. Does that equal 3? Yes. We'll check x equals negative 13 fourths. 4 times negative 13 fourths plus 1 times negative 13 fourths plus 1. Let's see, this is negative 13 plus 1 is negative 12. Let's see, what is this? This is 4 over 4. So this is negative 9 fourths. I get negative 12 times negative 9 over 4 is positive 12 times 9 over 4. 12 and 4 simplify to 3. This is again 27. Both worked. And go back there. I went through the fractions a little bit quick. Hopefully you're comfortable with fractions by now. I've been doing college algebra for a while. You can double check my math, but I ended up with 27 as the argument for both x equals 2 or x equals negative 13 fourths. All right. Let's just give a quick recap, a summary of the rules we've used. So what to do if what should I do if the following happens? Option 1, we have one side is raised to a function equals b. Here I want to take log base a of both sides. Log base a of a to the f of x equals log base a of b. The f of x comes down, and we've got log base a of a equals log base a of b, and log base a of a is 1. So we get f of x to some function equals log base e of b. The x is no longer in the exponent, and that's what we wanted. And recall, using the change of base, I could treat this as log b over log a if they don't go together well right now. Option 2. We start off with log base b of f of x equals a. Here we can convert. Recall, this means b to the a equals f of x. Or raise both or treat both sides as an exponent of base b. And you'll notice that's the same thing that this is the conversion formula. Remember when we converted, we said y equals log base b of x, and that turned into x equals b to the y. Same idea. Or we treat both sides as exponents. Finally, if we start off with 2 logs, we treat both sides as exponents of b. And recall, just like here, it goes away. We end up getting f of x equals g of x. Solve for x. And check arguments. F of x has to be greater than 0. G of x has to be greater than 0. And that's it for 4.5. I'll get this uploaded shortly. 4.6 is on applications. It's got exponential growth and decay. I'll have that up, and I'll be doing that next. They'll both be up today. And so, peace.